We're going to continue studying reactions of alcohol, so studying the transformations after a series of reactions. See what the final product is. I'm going to continue using the same molecule that I did in the other two videos. So let's starting with, say that was a molecule, because again, we're reviewing reactions. So here I have OH in this position, and here on dash I have an ethyl group. And the series of reactions that I have here, the conditions are the following. So I have first, we're treating the molecule. This is my reagent, is sulfuric acid, and is concentrated. Second reaction is, this is hydrobromination, but in the presence of peroxide. That's okay. And third, what I have here is we're going to be treating the product with either DBN or DBU. These are big, bulky bases. So let's study these reactions one at a time. So the first step says here that we are doing a reaction with sulfuric acid concentrated. And what that happens, that conditions favors the elimination reaction, and it is under acidic conditions. So what you will form here is an alkene. So under acidic conditions, remember that we always transform the OH into a good leaving group. Let me use another marker because this is not very bright. So let's do this. Grab out another color. Yeah, I like that better. Well, so much. Let's see. So what we're doing now in the reaction, well, of course, we need to make this a good leaving group. And it's that, and because that's secondary, and I did that, the reaction is happening through a E1 mechanism. And what we're forming initially is, say, I still have that center, I haven't touched that, and we're going to be forming a carbocation that is secondary. And then the other step is, under that condition, we remove the hydrogen, say that my base here is water, get the hydrogen, and you form, always in the E1 mechanism, you form the more substituted alkene. So the product of this reaction then, again, we're going to draw the alkene here. And now we see that the hybridization at this carbon was sp3, but this has changed to sp2. And again, this carbon is in the same plane as this plane, and this and that. So no need to do wedges and dashes. So that is a product after reaction number 1. And I'm going to erase this because I'm trying to see the space now. Just making it smaller. And here you have that. Just to get a little bit more room. Okay. So now second step says HBr under peroxide. So when we have peroxide in the hydrohalogenation, that happens anti-Markovnikov in the presence of peroxide. So here's your alkene. So the H is going to be at the more substituted and the bromine at the least substituted. That is the anti-Markovnikov product. So here's my reaction 2. That was reaction 1. Product was the alkene. Now reaction 2, again, is the anti-Markovnikov hydrohalogenation. And so that means that you will put the H here. And here I'm going to do not specify stereochemistry, and I'm going to tell you why. So that's what you do in the anti-Markovnikov. However, there's multiple things that you will form. Because once you do the anti-Markovnikov, and this is via radical, your intermediate is this. so a tertiary radical. So that center will be racemized, and also the other center can have the addition on either side. So you will have actually here 4 products with 2 different configurations here and here. But that's why I'm not specifying anything at this moment. But if the question asks you how many products in this stereochemistry, you should be able to draw it. Now, last step says DVN or DBU. These are bulky bases. And the importance of that is that these 2 reagents, either one, we're going to say they are strong bases, but they're not nucleophilic, meaning that we're not going to get any SN2 products. We're going to get only the E2 product. Now, how that happened? Well, because of that, because of the fact that they are really bulky, you're not going to get the decisive product. You're going to get the Huffman product, so the least substituted alkene. So we're going to go over to that side, and let's make this drawing a little bigger. If we consider, say that I have that, one of the possible products of that reaction. Remember that I can have that dash OH and that also because of the intermediate that you form. Now, this, because it's, again, strong base but not nucleophilic, you're not going to have SN2. And second, because it's bulky, you're going to favor the Huffman product. And here we need to remember that we have 2 hydrogens. And regardless if you have that on dash or wedge, you're always going to have 1 beta hydrogen that is anti to that. So the final product, then it will be forming the alkene at that position. So let's write here that either of the space is going to get, in this case, this hydrogen, make a double bond, and you form the Huffman alkene. So that is your product of that reaction. So you're going to keep that. And this, because of what we explained before, that is, you're going to have that plus the other product in which you have, so the enantiomer to that. So these are the products after you treat this molecule with DBN or DBU. So that's reaction number 3, reaction 2, reaction 3. Okay. I hope that these problems are helpful to you to understand all those changes. We're going to keep doing that.